All right, for this chapter, chemical bonding, we're learning about the bond between two what? Two atoms in a molecule. What is chemical bonding? It's the bond. Bond means what holds together. What is being held together is two atoms. Okay, one atom with another atom. Now, um, when atoms are held together, what do we call them? When you join two atoms together, yeah, that's a molecule, right? So these two atoms together, when they join, they become a molecule. Okay. Now these two atoms, they could be of the same type or they could be different. Now, if they're of the same type, for example, oxygen atom joining with oxygen atoms, then we get what? We get an oxygen molecule. So like that, if same type of atoms join, then the molecule that we get is called element, right? Like oxygen is an element. How many elements do we know? Totally, how many elements are there? 118 elements, right? So that is an element. Now, what if different atoms join? For example, hydrogen joins with oxygen. Yeah, then we get a compound, right? Like H2O, that is water molecule. What if carbon joins with hydrogen? Hmm? Do you know what you get? Carbon with hydrogen? Actually, you get thousands of different compounds because it depends on how many carbons joins with how many hydrogens. Okay, like for example, one carbon can join with four hydrogens, CH4, or two carbons can join with six hydrogens, or two carbons can join with four hydrogens, or two carbons can join with two hydrogens. See, there are so many possible options for compounds to form. So, how many compounds are there in the world? See, elements we know there are 118 elements. How many compounds are there? It could be in millions, right? Because all these 118 elements they can join with each other in any ratio. I mean, in many different ratios. Okay, your last chapter in chemistry is organic chemistry. In that, you're learning especially about carbon compounds. How carbon can join with so many different other elements. Okay, that's a whole branch of chemistry, organic chemistry. Okay, just like how biology has two branches. What are the two branches of biology? Zoology and botany. You heard of that? Botany is to study of plants, and zoology is study of animals. And when you go to 11th and 12th, I think they split it. At least in states where I studied state syllabus, we had two subjects, zoology and botany. So like that, chemistry also is divided into many branches. And one of the branches, organic chemistry, where you study about carbon compounds. Okay. So in this chapter, you are studying about some elements and some compounds. The bond between those atoms of an element or the bond between the atoms of a compound. Okay. Okay. So before we do that, you need to know some basic things like the structure of an atom. Okay. You know the structure of an atom that in the center you have the nucleus. What is inside the nucleus? Neutrons and protons. Neutrons have what charge? No charge. Okay. So when you're writing a neutron, uh, okay. Yeah. See, it's here in the book. I'll explain to you why these numbers like this, okay? But yeah, so neutrons have no charge. Then protons have what charge? Positive charge. And then the outermost electrons in the orbits, they have the negative charge. Okay, so the charges are given over here. And here you can see their masses. Okay, so which one's mass is negligible? Electrons. Okay, the electrons have negligible mass. And that's why we don't consider electrons when we find atomic mass or the mass number. To find mass number, we only add the number of. Tell me what is atomic number and what is mass number? I hope you all remember these definitions. What is atomic number? Definition of atomic number?
Number of protons basically.
Yeah, it's a number of protons or it's a number of electrons. Protons are positive, electrons are negative. So it's any one of their numbers because the number of protons and electrons are always equal. What if an atom has 10 protons and 10 electrons? What is its atomic number? If an atom has 10 protons, 10 electrons, what is its atomic number? 10. All right. Okay. Then what is mass number? Mass number is the number of, yes, protons plus neutrons. Why we're not adding electrons?
The number of protons.
Because protons are equal to neutrons.
Yeah, it's big. No. It's because the electron's mass is negligible. Okay, see, when we find mass number, mass means weight. We want to find the weight of the whole atom. So if I want to, I've given you this example before. Suppose I want to find the weight of all living things in this room. How will I find the weight of all living things in this room? We will add all our masses. Okay, but there are some bacteria, some mosquitoes, some flies. Why we're not adding their mass? It's negligible. If you add their mass also, it's not going to make any difference to the total mass, right? Hardly any difference. That's how an electron is. If you add the mass of an electron, it's not going to make any difference because its mass is negligible. So when we're finding the mass of an atom, we only add protons and neutrons. Clear, everyone? Okay. Now, how do we represent the atomic number and mass number when we write an element? Tell me an element. Aman, tell me an element.
Okay.
Oxygen. Any other element? Lithium. Okay, let's take lithium. Now, lithium. What is the atomic number of lithium? 3. Where do we write the 3? Top, down, left, right? Down, left. Okay, here. That's where we write the atomic number. This is atomic number. Atomic number is represented by which alphabet? Z. Okay. So Z is written here down. That is the atomic number. And mass number. What's the mass number of lithium? It's either double or double plus 1. We have made a table, no? Double or double plus 1. So for lithium, what is it? It's double plus 1. So 7. Okay. So 7 is the mass number, which is represented with A. Okay, Leah, clear? Now you don't have to memorize the mass numbers, but you have to memorize atomic numbers of all elements, basically first 20 elements. Okay. Tell me how many electrons, how many protons, and how many neutrons are there for lithium? How many electrons? 3. The atomic number is the number of electrons, right? So 3 electrons. Also, atomic number is the number of protons. So there will also be 3 protons. What about neutrons? 4 neutrons. How we got 4, Aman? The mass number. What's the mass number's definition? Or how do we find the mass number is adding proton plus neutron. That is 3 plus 4. Proton plus neutron. 3 plus 4 is how much? 7. Okay, so it should add up to 7. Or easy way, what you can do is to find this, you can just do A minus Z. That is 7 minus 3. Right? You do 7 minus 3, you'll get the number of neutrons. Okay. Now remember this, okay? Where 7 is written and where the 3 is written. The mass is written on the top, the number, atomic number is written down. Okay. So if you look at how protons, neutrons, and electrons are represented. See, protons is represented how? +1 down and the 1 on top. So what is this down? Okay, look at neutron. Neutron 0, 1. Electron is -1, 0. Can you tell me how? Why did they put these numbers? Why are we representing it like this? What's the number on top? 1, 1, 0. What is that number on top? For proton it is 1. For neutron it is 1. For electron it is 0. There's a mass. See how we represent mass on top, no? So the same way here we're representing the mass on the top. So electron's mass is 0. And then down, what do we represent for? The charge. Proton is +1, neutron is 0, electron is -1. So charge is the atomic number only. right? If there are 3 protons, 3 electrons, then what is the charge? For proton, it is +3, and electron is -3, right? So the charge is basically the atomic number. How many electrons are there? How many protons are there? Okay. So remember this, how it is, how it is represented. You will have the same alphabets used in physics in the second last chapter. Okay, there's a chapter called radioactivity, no? Or last chapter, I think that is. Have you seen your index? You went through the index of your physics. The last chapter or second last chapter is nuclear reaction or radioactivity. In that also, you will have these same alphabets for protons, electrons, and neutrons. Okay. All right. Periodic table. Let's open the periodic table. Okay, in the periodic table, we're going to look at group 1A, 2A, 3A, 4A, 5A, 6A, 7A, and the 0 group or 8A. So now where are the metals? Where do we find metals in the periodic table? Group 1A, 2A, and mostly 3A. These are the metals. And where do we find non-metals is mostly 4A, 5A, 6A, and 7A. There is some exceptions because there are some properties trends that go diagonally. So you notice some, like if you see the third group, you see both. Okay, let's see the fourth group. In the fourth group, you see carbon, which is a non-metal, and you also see tin, which is a metal. Okay, so there are some mix, but generally you see all metals on the left and all the non-metals on the right. Oh yeah, we saw the trends, in the first chapter. What happens when you go from left to right to the metallic character? Decreases. The non-metallic character increases. Okay. Now, what is the valency of all elements in group 1A? +1. 2A +2. 3A +3. 4A -4 or +4, mostly -4 because we only look at carbon. 5A -3. 6A -2. 7A -1. And last 8A is 0. Okay. So, yeah. So all metals, they generally have 1, 2, or 3 electrons in their outermost orbit. And non-metals will have 4, 5, 6, or 7 electrons in their outermost orbit. Right? Metals 1, 2, 3. They have 1, 2, or 3 electrons in their outermost orbit. Non-metals will have 4, 5, 6, or 7. Right? So metals, what do they do to become stable? They lose electrons. And non-metals, what they do? They gain electrons. This chapter is actually a revision of what you studied in 9th standard. Okay, you had the same chapter in 9th standard. You remember it? Chemical bonding, huh? Fourth chapter. You remember the number also. In that we learned about these bonds. Okay. Yeah. So this is just a revision, but just to be clear, we're going through it in detail. Okay. All right. Now, when we see combination of atoms, when atoms combine, now when metals and non-metals join, how do they combine? The metal has either 1, 2, or 3 electrons. The non-metal will have 4, 5, 6, or 7 electrons. So the metal wants to donate electrons and the non-metal wants to take electrons, right? So this type of bond between a metal and a non-metal is a very strong bond because the metal will become positively charged. Since it donates electrons, it becomes positive. And the non-metal, since it gains electrons, it will become negatively charged. And so the bond between the metal and the non-metal will be very strong because one is positive, one is negative. It's like a magnet. When you bring North Pole and South Pole close to each other, there's an attraction, right? Same thing here. You'll see a very strong bond between the metal and the non-metal. And what is this bond called? Tell me. It's an ionic bond, or it's also called as electrovalent bond. Okay, electrovalent and ionic bond is the same thing. It's a bond between a metal and a non-metal. It happens when there is transfer of electrons. Transfer from where to where, Aman? Electrons get transferred from metals to the non-metals, right? Okay. So in this chapter, you're learning about 3 ionic compounds. Okay. You're learning about what are the 3 ionic compounds you'll be studying. Just check in your textbook. I think you'll have different number. In this book, you have, yes, NaCl, Then magnesium chloride, MgCl2, and calcium oxide, Cl. Any more?
Potassium bromide and calcium chloride.
But admit there's diagram for all of them. Yeah, let's write it anyway. Potassium bromide,
Yeah.
KBr, and
Calcium chloride.
that is same like this, KCl2, same like this. Okay. Okay. All right. So these are the different ionic compounds. They are called what? Ionic compounds. The bond between Na and Cl is called ionic bond. The whole NaCl together is called ionic compound. Ionic compounds have ionic bonds. Okay. All right. Then the second type of bond that you'll be studying is between a non-metal and a non-metal. Okay. Now, since both are non-metals, they could either be the same non-metal or they could be two different non-metals. Okay. But whatever it is, the bond between two non-metals, that bond is called what? Covalent bond. Okay. Now, do you think this bond will be strong? It won't be very strong. Okay. Because see, both are non-metals, which means both will get a negative charge. Okay. So when two negatives are brought together, there is no attraction actually. Okay. But in this case, there is a very slight attraction. There are some forces that hold these two non-metals close to each other. They're called van der Waals forces. Yeah, I think it's there in your book. When it comes, we'll see that. Okay. The forces in between the covalent structure, between the covalent compound is van der Waal. Okay. Anyway, the bond here is formed by sharing of electrons. Right. Both of them will share. If one non-metal shares one electron and the other non-metal shares one electron, so those two electrons will belong to whom now? Those two electrons which took part in the sharing, they belong to both the non-metals. They belong to this non-metal also and to also the right side non-metal. Okay, so whatever is shared belongs to both. In ionic, how it is? It's transfer. If the metal gives away one electron, now that electron is with whom? It's with the non-metal. That metal doesn't have it. But in covalent, how it is? First of all, both have to share. And when both share, those electrons belong to whom? To both. It's like this non-metal has those two electrons, and this right side non-metal also has those two electrons. Okay, so that is covalent bond. Now I think you have 8 different covalent compounds in your book. Okay, we'll see what they are later on. And then last, you have another type of bond called coordinate bond. Now, coordinate bond is something new which you do not have in the 9th standard. Coordinate bond, it's between an ion and a covalent compound. Little complex it is. It's between an ion. What's an ion? An ion is a charged particle. It's either positively charged or negatively charged. So that ion combines with a covalent compound. For example, H plus is an ion. It joins with a covalent compound like H2O. And what does it form when H plus and H2O join? It becomes H3O plus. H3O with a charge. Okay. There's another example in your book. Hydrogen itself with ammonia. What's ammonia's formula? NH3. So what will happen when H plus joins with NH3? NH4 plus positive. Okay. So these are the two coordinate compounds that you're studying, H3O plus and NH4 plus. Okay.
Coordinate bond is between ion and covalent.
Yes, coordinate bond is between an ion and a covalent compound. Okay. So now let's look at starting with ionic. Okay. Ionic bond. Okay, the first ionic bond is between sodium and chlorine. So sodium has how many electrons? What is the atomic number for sodium? Huh? Okay, that's the electronic configuration. So there are 11, right? 11 is the atomic number, so 281. And chlorine, what's the atomic number? 17. So the electronic configuration is 287. We've seen this many, many times, right? This is the first thing, the most common compounds that we always study, right? Okay. Now, how do they form? You have to draw this in two different types of diagrams, okay? So the first diagram is the electron dot structural diagram, the most important one for you. The atomic structural diagram, you had done this in the 9th standard, if you remember. You had drawn the whole atom, then you showed the electron being transferred. You remember this, all of you? Okay. But now in 10th standard, you're mostly focusing on this electron dot diagram. Okay. So let's see how this electron dot diagram is. So first you will write Na, and you will only represent the electrons in the outermost orbit. So in the outermost orbit, there's one electron. Represent that as a dot. Okay, just put it somewhere on the right side here. Now Na joins with chlorine. Chlorine has 7 electrons in the outermost orbit. So mark those 7 electrons with a dot, or sometimes you can do it with an X. But here they're using a dot. In your book, what are they using? See that? That's not the type of. Not this, this is orbit. Where is the electron dot diagram? Next question. Is it a dot or? Yeah, it's dot. Okay. So representing all the outermost electrons with a dot itself. Okay. And then you show an arrow showing where the electron is getting transferred. So from Na to Cl, there is a transfer of electrons. Now, when the transfer takes place, what happens to Na? Na will become an ion. So put a bracket like this and put 1 plus. Okay, Na will become 1 plus and Cl will become what? 1 minus, right? But for Cl, you have to show the electrons now that are there. Okay, so that is 1, 2, 3, 4, 5, 6, 7, 8. So you're showing that outermost electron orbit which used to be there. Sodium doesn't have that outermost electron now. It's gone. It disappeared. So you're not showing any electrons. Chlorine from 7 it changed to 8. And they became ions, right? Sodium became a positive ion and chlorine became a negative ion. Then you put one more arrow and you write it as NaCl. That is the name of the compound that is formed. So this is the full electron dot diagram called electron dot diagram.
The ionic bond and electrovalent bond is same.
Yes, it's the same. Okay, everyone clear how to draw electron dot diagram? Now, just we'll look at the electron dot diagram for the, okay, before that, what you see down here is the atomic or orbit structural diagram. So in this, how it is. So here, sodium, you're showing with all the orbits, 3 orbits, outermost orbit has 1 electron. Plus chlorine, chlorine also has 3 orbits, outermost orbit has 7 electrons. So here, Na, from 3 orbits, it becomes 2 orbits. And chlorine has its 3 orbits with 8 electrons. So Na becomes Na1 plus, and chlorine becomes Cl1 minus. That is the orbit structural diagram. Okay. Now, orbit structural diagram takes a long time to draw. Okay, so mostly they'll give you electron dot diagram, but you should know how to draw both. All right, just draw the electron dot diagram for sodium chloride, and then we will just see the other 2 examples that are in your book. Okay, clear how to draw the structure, orbit diagram. Now let's look at the next one, which is calcium oxide. So calcium has how many electrons in the outermost orbit? And look at this diagram and tell. Calcium is number 20. So what is the electronic configuration? 2882. So there are 2 electrons in the outermost orbit. Now when it joins with oxygen, oxygen has how many electrons? 6. So calcium needs to donate 2 and oxygen needs 2. So one calcium will join with one oxygen, and that's how you get calcium oxide, CaO. So calcium's valency becomes 2 plus, oxygen becomes 2 minus. How many is it clear? Sure? You look a little confused. Okay. All right. Then the third example is magnesium chloride. Now, magnesium is a little different. Magnesium has how many electrons in the outermost orbit? Magnesium is number 12. So 2, 8, 2. 2 electrons. And when this joins with chlorine, chlorine has how many electrons in the outermost orbit? 7. So magnesium needs to donate 2, but chlorine can only take 1. So how do they join? One will go here. What about the second electron? So here this chlorine has 7. So it gets 1 from magnesium, 1 electron. Where does the other one go? Can it go here? No, chlorine already got its 8. So where does this other electron go? Stays there itself? Then it won't be stable. What?
We'll go to another.
Yeah, another chlorine atom. That's why Mg, when it joins with Cl, it's not MgCl. It is what? MgCl2. Because one magnesium atom joins with 2 chlorine atoms. That is the structure, MgCl2. Okay? So here you can see the reason is because magnesium wants to donate how many? Wants to donate 2. Chlorine can only take 1. Is this clear, everyone?
Okay, can you read it once again?
Magnesium wants to donate 2 electrons, but chlorine can only take 1 electron. Right? So magnesium needs to join with 2 chlorine atoms to donate 1 electron each to each of them. Okay? So yeah, how do you write this completely? This will be in the last. Before this, you will write what? You will write Mg with its valency. What's its valency? 2 plus. And chlorine, for chlorine, you'll put 2 in front of it because there are 2 chlorines. That's 1, 2, 3, 4, 5, 6, 7, 8. And the valency here you'll write 1 minus. 1 minus. The chlorine's valency is 1 minus. There are 2 of them. Okay, draw this electron dot diagram for magnesium chloride. Okay. So what are the 3 compounds we just saw? Ionic compounds. First one is sodium chloride. Second one was, and we didn't draw this, but what was it? Calcium oxide. And the third one is magnesium chloride. Okay. There are few more like KBr. Okay, so we can just orally see KBr, potassium. What is the valency? How many electrons in the outermost orbit? Potassium is 19. So 2881. It wants to donate 1 electron. And bromine is, it's a halogen, so 7th group. So 7 electrons. So potassium donates 1 electron, bromine takes that 1 electron. Clear? Same like NaCl. And calcium chloride is same like magnesium chloride. Calcium wants to give 2 electrons, chlorine can only take 1. That's why you have 2 chlorines joining with calcium. Is that clear, everyone?
Yes, sir.
We'll end with this. Tomorrow we'll continue with chemistry and biology. Okay, first. Yeah, we'll do chemistry first. Aman, come first. Don't come late, otherwise then you'll be waiting on. All right, I'll see you all in the next class.
Yes, bye.
Bye. So yesterday we saw all the electron diagrams for ionic bonds. Ionic bond was a bond between a metal and a non-metal. The metal donates electrons and the non-metal receives electrons. The ionic bond is very strong. Okay, in other words, you have to break the bond, you need a very high amount of energy, heat energy. That means they have high melting point and high boiling points. Understand? High temperature to boil it or high temperature to melt it. So we saw 5 compounds in ionic bond. Which were the 5 compounds in order? First was NaCl. Second was C, calcium oxide. Then magnesium chloride. Okay, these were 3. And then 2 more we saw. KBr and CaCl2. I mean, KBr is just like NaCl and CaCl2 is just like MgCl2. So we didn't draw them. Okay, so these were the 5 examples of ionic compounds. There is one more thing. For each of these, you should be able to also draw the ionic equation. Ionic equation means what happens to each of them. Like for example, let's look at sodium. So sodium, what happened to sodium and what happened to chlorine? So the sodium turned into an ion. Sodium turned into Na1 plus, and calcium turned sodium chloride. Sorry, Pl. Chlorine turns into what? Pl1 minus. Right. That is what happened to these two. So how did sodium turn into Na1 plus? Did it take an electron or did it give an electron? It donated an electron, right? So we have to write like this: minus one electron. This is the symbol for electron, E with a dash on top. We don't need to put their atomic number and mass number like how we saw. Just E with a dash on top. So sodium minus one electron, and so it became Na1 plus. And chlorine added one electron, and so it became Cl1 minus. Okay, so this is called the ionic equation. Now, what do we call addition of electrons? You've heard of oxidation and reduction. Addition of electron is what? What's the meaning of the word oxidation? Adding oxygen. It also means removing
Hydrogen.
hydrogen. It also means removing electron. Okay, and reduction is the opposite. This is very important. It keeps coming in all the chapters. Okay, reduction means removal of oxygen, which also means addition of hydrogen or addition of electron. Okay, so here what's happening to chlorine? Is it oxidation or reduction?
Reduction. The reducing hydrogen or reduction of hydrogen.
Ahmed?
In oxidation, reduction of hydrogen or removing hydrogen.
Don't use the word reduction. Removal. Removal of hydrogen, removal of electron. Okay. Voltage fluctuation. So chlorine, what's happening here? There's addition of oxygen. So addition of oxygen means reduction. And here, removal of electron. Removal of electron is oxidation. Okay, write this down. Okay. Now, what's the next type of bond? Covalent bond. So here what we saw, the first starting of the chapter, atoms join to form molecules. These atoms could be same atoms or they could be different atoms. For ionic compounds, what are the two atoms? One is a metal, one is a non-metal. Correct. So they are elements or compounds that we saw in all these ionic compounds. Were they elements or were they compounds? They were compounds because both the atoms were different. Correct. One metal, one non-metal. Now for covalent compounds, both these atoms will be non-metals. They could be the same non-metal or they could be two different non-metals. Okay, if they are the same non-metals, then that is an element. If they are two different non-metals, then it's a compound. Okay, so to keep this in mind, you're going to see some elements and you're going to see some compounds. If the two atoms are same, then they are elements, and if the atoms are different, then they are compounds. Whatever it is, both the atoms will be non-metals. Okay, so let us see all the different covalent compounds that we're going to study. First one is what? Hydrogen. That means hydrogen plus hydrogen. There. Next is chlorine. Cl plus Cl. That gives Cl2. Then oxygen. O plus O gives O2. Nitrogen. N plus N N2. So these were all elements, 4 elements. What are the 4 elements? Tell me. Hydrogen, chlorine, oxygen, nitrogen. That's it. So 4 elements, and we're going to see 4 compounds. So what are the 4 compounds? Carbon tetrachloride, carbon C and Cl4. Okay, see, carbon is a non-metal, chlorine is also non-metal. We'll see the structure. Next, methane. Do you know the formula for methane? Anyone? That is ammonia. Oh, no, and ammonium. CH4. CH4. Right. So that's carbon and hydrogen. Both are non-metals. Next, water. So hydrogen and oxygen. Again, both non-metals. And last is ammonia. Formula? NH3. In nitrogen and hydrogen. Both non-metals. So all of these 8 compounds or 8 covalent molecules, they're all made up of non-metals. Okay. So let us see the first one, hydrogen.
Anna,
Yeah.
when is it a non-polar covalent compound or a polar covalent compound?
Yeah, I'll explain that. Okay. That is, we will do that. Maybe not today. After I explain all these 8, then you'll understand about something called polar and non-polar. Okay. All right. Anyway, so hydrogen. What is the structure of hydrogen? This is the orbit diagram. You can see the full structure, right? So there's only one orbit, and that one orbit has one electron. Now, hydrogen needs 2 electrons. So what does it do? It needs 1 electron. So if it finds another hydrogen, it cannot take that electron from hydrogen. If it takes it, what will happen is that other hydrogen will not have any electron. So it won't give. So what they both do is they share their electrons. So now these 2 electrons, remember, one from one hydrogen, one from the other hydrogen, together are sharing these 2 electrons. So these 2 electrons belong to both the hydrogens. So the first hydrogen also has 2 electrons. Next hydrogen also has 2 electrons. Okay. All right. So let's see how to draw this. We will draw the electron dot diagram. It's a little different than the electron dot diagram that we drew for ionic compounds. So here, hydrogen, draw that 1 electron in the outermost orbit, plus the second hydrogen. For this also, you draw the electron over here. And when they add H plus H, you get H with both the electrons in the center. So this way you're showing that both these electrons, they came right to the center of the hydrogens and they are sharing. And then you can put OR, and you will show that bond between those 2 electrons as a single bond like this between the 2 hydrogens. Then you'll put one more arrow and you'll write H2. This is the full electron dot diagram for the structure of hydrogen. Is this clear? What you can also do is you can just put a dotted line like this around these electrons that are taking part in the sharing. Okay, to show that those are the 2 electrons that are going to share with each other. Okay. Just draw this. Write heading covalent compounds and write hydrogen. Okay, next we'll see chlorine. So chlorine has how many electrons in the outermost orbit? 7.
7.
So chlorine needs how many electrons now? Needs 1. Remember this. If it needs 1 electron, it has to share 1 electron. It's like you give and take. You give 1 electron, you'll get 1 electron. It's like that. See, hydrogen, it needed 1 electron, so it shared 1 electron. It only had 1 electron to share, it shared that. Now chlorine has 7 electrons. But if it needs 1 electron, what it has to do? It has to share 1 electron. It doesn't have to share all 7. Okay, so this 1 electron over here, we will share with the other chlorine. Okay, so when it shares, what happens? How do you draw it now? So you'll draw 1, 2, watch carefully, 3, 4, 5, 6, 7. These are its own. plus the other chlorines, 1 electron will be here. So these are the 2 electrons which took part in the sharing. One from the left side chlorine, one from the right side chlorine. And then you draw all the other remaining 6 more. You see? So now around this chlorine, how many electrons are there? 8. And around this chlorine, 8. Is that there? So both have 8 electrons now around the around each. Then you put the OR, and then you show chlorine with 1 bond between 1 pair of electrons. 1 pair of electrons will have a single bond. Then you put the next arrow and you write Cl2. Draw this. Okay, the last one we'll see is oxygen for today. Oxygen has how many electrons in the outermost orbit? 6. So how many does oxygen need now? It needs 2. If it needs 2, it has to share 2. Okay, so the 2 electrons that it's going to share, you draw it on the right side of the cell. Okay, whatever is going to be shared, you draw it on this side. The remaining, you draw it anywhere you want. Anywhere means evenly spaced. So that's 1, 2, 3, 4, 5, 6. Okay, here also we'll draw it the same way. 1, 2, 3, 4, 5, 6. Okay, then a plus in the middle. Now the electrons that are going to take part in the sharing, draw dotted lines around them. That's one. This is the other. So that will be O. Those electrons that took part in the sharing, put them right in the center like this. The remaining. So 4 electrons have taken part in the sharing. So remaining how many? 5, 6, 7, 8. See, these 8 electrons now belong to this oxygen. Same way on the other side also, 8 here. That is 1, 2, 3, 4, 5, 6, 7, 8. Clear? So what type of a bond is between these oxygen atoms? It will be a double bond. So you have one oxygen, second oxygen with a double bond in between. One bond between one pair of electrons, second bond between the second pair of electrons. Okay, 2 electrons create one bond. 4 electrons will create 2 bonds. So 6 electrons will create 3 bond, a triple bond. Okay, which we'll see it later on. All right, and then you put one more arrow and put O2. This is the structure of oxygen, or the electron dot diagram for oxygen. Okay, draw this. Okay, is this much clear, everyone? Okay, so the fourth one we see is nitrogen. Nitrogen has 5 electrons in the outermost orbit. So it needs 3 more electrons. So to get 3 more electrons, it shares 3 of its electrons, and that way it gets 5 electrons in the outermost orbit. Right? 5 plus the 3 which is from the other nitrogen. And this is the electron dot diagram for nitrogen. So we have seen electron dot diagram for 4 elements: hydrogen, chlorine, oxygen, and nitrogen. So in hydrogen and chlorine, we had single bonds. Oxygen was a double bond. Double bond means it needed 2 electrons. Nitrogen had a triple bond, which means it needed 3 electrons. You don't have 4 bond or anything. Okay, 3 is the maximum. Triple bond is the maximum that there is. Okay, now we will go into compounds. 2 nonmetals joining with each other. So the first compound that you have is carbon tetrachloride. Now, before we even write the formula, let us see carbon and chlorine, since it's between carbon and chlorine. So carbon is 6. Carbon's atomic number is 6. Electronic configuration would be 2, 4. Okay, that means carbon needs how many electrons to become stable? It needs 4 more. It has 4, it needs 4 because 4 plus 4 is 8. No, it needs 8. So if it needs 4, it has to share 4. That means it has to share all the electrons that it has in the outermost orbit. Okay. Now it's joining with chlorine. Chlorine, what is chlorine's atomic number? 17. Its electronic configuration is 287. Now chlorine only needs 1 electron to become stable, which means chlorine will only share 1 electron. And carbon needs how many? 4. Right. So carbon will join with 4 chlorines. That's how the bond is formed. Okay. Let's look at the orbit diagram. This is the orbit diagram of carbon and chlorine. So you have one carbon in the center with its 4 electrons in the outermost orbit. And each of those electrons will share with that 1 electron from chlorine. So that way chlorine with it has 7 plus it shares 1, which means it gets 1. So it has 8. So that's for all the chlorines. And the carbon has 4, it needs 4. So since it shares 4 of its electrons, it gets 4 electrons. So that way all of them have 8 electrons in their outermost orbit. Is that clear, everyone? Chlorine had 7. So since it shared 1, it got 1. So it became 8. So like that every chlorine shared 1 of its electrons, so it became 8. And on carbon, on the other hand, it had 4. So it shares all 4 electrons, and so it gets 4 more electrons from the 4 chlorines. And that's why carbon is also stable. Okay, so this is the orbit diagram. See how the orbit diagram is drawn. Okay. Here actually they do not draw all the orbits. They do only the outermost orbit because the other orbits are not needed. Okay. So for orbit diagram also, it's not necessary to draw all the orbits. For ionic bonds, they drew all the orbits. But for covalent bonds, for covalent compounds, they're only drawing the outermost orbit for orbit diagram. Okay, so that's all you need to draw. Now look at the electron dot diagram. Okay. So similar to what we saw before, but here we're going to represent the electrons using different symbols. So carbon's electrons, carbon has 4 electrons in the outermost orbit, we'll put 4 dots. And chlorine has 7. So for chlorine's electrons, we'll put a X. So you don't get confused between chlorine's electrons and carbon's electrons. Okay. So 1, 2, 3, 4, 5, 6, 7. Only the electron that's going to take part in the sharing, you draw it separately like this. Put a plus in between. And then show that these 2 electrons are going to take part. Right? So like that, do for each of them. Draw chlorine, draw the 7 electrons, 1, 2 on top, 1, 2 on this side, 1, 2 on the left side, and only 1 at the bottom. Near that carbon, you're drawing only 1 electron. Put a plus in between, and then draw dotted lines. Clear, everyone, how to draw it? So like that, all 4 you'll draw. The next step, you'll draw the same thing, but without the plus. Means you'll draw the electrons next to each other without the plus. So then it will look something like this. And then you can put an arrow or and show bonds. Carbon in the center with 4 bonds around it, and then that is CCl4. Okay, all of you draw the structure. Okay, is that clear, everyone? You finished drawing this much? There is something about polar and non-polar. So let me explain that one to you now. Actually, I'll explain that to you after I finish all 8, because then only you can compare each one and understand it better. So yeah, hold that for now till we finish all the 6. Okay, so today itself, all the 8. Today itself, we'll be seeing what that is. Okay, the next compound after carbon tetrachloride, CCl4, is methane. Okay, now we're not going to draw this, but it's similar to this. Methane also has, the formula for methane is CH4. That means 1 carbon in the center and 4 hydrogens around that carbon. So carbon is sharing how many electrons? Carbon is sharing how many electrons? No, totally carbons, how many electrons are being shared? 4, because it needs 4. Right, carbon needs 4, so it's sharing 4. Now to whom it is sharing all those 4? 1 to each of the hydrogens. Hydrogen needs only 1 electron, so hydrogen shares only 1. but carbon has to share 4. So same like carbon tetrachloride, you have methane. Is that clear? So diagram is same like this. Just write the name number 6. You can leave that space empty to do it as your homework. CH4. The next one is water, H2O. So how is the structure of water? So H2O means 2 hydrogens and 1 oxygen. So obviously oxygen would be in the center and you would have 2 hydrogens on both the sides. Oxygen in the center, hydrogen on both the sides. Can you draw the structure diagram without any help? Draw it. Just draw the electrons in the outermost orbit. Come on, do it. Draw the structure, everyone. Raman, you're not drawing. Draw H2O structure. Finished? Show me, all of you, what you drew. Out. Electron dot. You do orbit out. Okay, draw electron dot also. Draw the electron dot diagram. So oxygen has 6. 1, 2, 3, 4, 5, 6. Draw it like this. Hydrogen has 1. Okay, see how the electrons are over here. These 2 are for hydrogen. 1 of hydrogen, 1 of oxygen. Same here also. These 2 electrons for hydrogen. And for oxygen, all the 8. 6 of its own, 2 from each of the hydrogens. Then H bond O bond H, which is H2O. Ammonia. Ammonia, I'm not, you'll try this on your own. I'll tell you the formula. I mean, you know the formula. Ammonia is what? NH3. Okay, so try drawing the structure. Whatever is lesser will be in the center, whichever has lesser atoms. So nitrogen in the center, hydrogen around it. So how did you draw it? There's nitrogen in the center, and you have to think like this. Nitrogen has 5 electrons, so it needs 3. It means it has to share 3. So it's sharing 3 with 3 hydrogens. 1 hydrogen here, here. And 2 of the nitrogen's electrons don't take part in the sharing. Correct? Okay. Now, for the compounds, okay, let us see what is a polar and a non-polar compound. Okay, the word polar means charged or charges which are not equally distributed. Means if one side is more positive and the other side is more negative, then we call it polar. Okay, polar means charged. So one side has one charge, other side has the other charge. That is polar. Okay, so if we it's the rules are slightly different for elements and for compounds. Okay, for elements will all be non-polar. Non-polar means the charges are equally distributed. Polar means what? Charges are unequally distributed. One side more positive, one side more negative. Non-polar means what? No charge or charges are equally distributed. Okay, so if you see hydrogen, it's like a mirror image. There's equal charge distribution. That means the left side hydrogen is sharing 1 electron, right side is also sharing 1 electron. So it is non-polar. Okay, it's even. Chlorine also non-polar, 1 from each side. Oxygen also would be non-polar, and nitrogen also non-polar. Means they're like a mirror image. They're symmetrical. That is non-polar. Now, if you go to compounds, in compounds you have to look at the middle element, the one at the middle. So, for example, here, what is in the middle? Carbon. And then you see in carbon, is there any electrons that have not taken part in the sharing? No. Every electron has taken part in the sharing, right? So it is equally distributed. All the electrons are equally distributed, and that is non-polar. What about methane? Look at the center atom, that is carbon. Here also all the 4 electrons have taken part in the sharing. So here also equally distributed. So that is non-polar. Now look at water. See in the center atom, that is oxygen. Out of the 6 electrons, how many have taken part in sharing? Only 2. There are 4 electrons that have not taken part in the sharing. So this is unequally distributed. This is polar. Here everyone, what's polar? When all the electrons have not taken part in the sharing from the middle element, then it is polar.
The last one.
From the last, what?
Okay.
Only the last orbit is taking part in the sharing, right? So we're only looking at the last orbit. And that too not for the hydrogens, only for what's in the middle. Middle is oxygen. Out of 6, only 2 have taken part in the sharing. The remaining 6, not 6, 4. The remaining 4 electrons have not taken part. So it's unequally distributed. We can say there are more negative charges in the oxygen because these electrons are there, right? So hydrogen is more positive, oxygen is more negative. That is polar. And look at ammonia also. Ammonia in the center, nitrogen, there are 5 electrons. From 5, 2 have not taken part in the sharing. So this is also polar. So it's very simple. Okay. For elements, how it is, all elements are non-polar, equally distributed. For compounds, if there are any electrons in the middle atom that have not taken part in the sharing, then it is polar. Like water and ammonia, they are polar. Now, these electrons that have not taken part in the sharing, they will always be in pairs. So for water, how many pairs of electrons have not taken part in the sharing? Here, this electron, 2 electrons have taken part in the sharing. 4 electrons, that is these 2 on top and these 2 down. So 2 pairs of electrons have not taken part in the sharing, right? So these 2 pairs are called lone pairs. There are 2 lone pairs. Lone means alone. Okay, so there are 2 lone pairs for water. What about ammonia? How many lone pairs? This electron has taken part, second and third. 3 electrons have taken part in the sharing. How many lone pairs are there? 1 lone pair. Okay, so this has 1 lone pair. So if there's any lone pair of electrons, then that's polar. Right. So ammonia has 1 lone pair, so ammonia is polar. Water has 2 lone pairs, so water is also polar. If there's no lone pair, then non-polar. Is everyone clear what's the difference between polar and non-polar? Okay, so now tell me the bonds without looking. What are the how many bonds are there in each of these elements? So starting with hydrogen. Hydrogen has how many bonds? 1 single bond. You have to tell the number of bonds and what type of bond it is. So hydrogen has 1 single bond. Chlorine, 1 single bond. Oxygen, 1 double bond. Look at the diagram. Oxygen has a double bond, no? See, if it's between the same 2 atoms, that is 1 bond. If it's between different atoms, then they are different bonds. So for oxygen, it is 2 oxygen atoms, and the bond is between those 2 oxygen atoms, right? So that is 1 bond. But what type of that bond is? What type of bond is it? It's a double bond. Okay. Next, nitrogen. What bond is between the nitrogen atoms? 1 triple bond. Okay. Next, what's next? Carbon tetrachloride. Here, what bond is for carbon tetrachloride? 4 single bonds. Okay, because see, each bond is between a different atom. So 4 chlorines are there. Each bond is between each of those chlorine atoms. So there are 4 single bonds. Next, what's next? Methane. Here, methane. What bond? 4 single bonds. Oh yeah, full word is 4 single covalent bonds. All these are covalent bonds, right? So 4 single covalent bonds. Next, water. 2 2 single bonds. And here ammonia, no, what's last? Yeah, ammonia, 3 single bonds. Okay, is everyone clear about the bonding? Okay, you all just rejoin the meeting. And when the meeting rejoins, those whose cameras are off, you'll be put back into the waiting room. Okay. I'm tired of telling you to turn your cameras on. I'm at the boys.
Right.
Okay, so we have finished all electrovalent bonds and covalent bonds. What's the next type of bond? I told you the name that day. What is it?
Coordinate bond.
Coordinate bond. Okay, that's the third type of bond. Coordinate bond. Or it's also called as coordinate covalent bond. Okay, so it's called covalent. That means what type of is it sharing or transfer of electrons? It's sharing of electrons. Okay. Now coordinate bond takes place between what all? It's between an ion and a covalent compound. Covalent compound, not covalent element. Okay, what are the covalent compounds we saw? Carbon tetrachloride, methane, ammonia, water. Right. But it should be a covalent compound that has lone pairs. That means which are the two? Water and ammonia. Basically a polar covalent compound. Correct, because polar covalent compounds only have lone pairs, right?
Sir, known pairs.
What?
Known pairs.
Yeah, it should have a lone pair. Polar covalent compounds have a lone pair, right? We just saw water and ammonia. Water has 2 lone pairs and ammonia has 1 lone pair. Okay, so if there's a lone pair, then it is a polar covalent compound. So that's what's taking part here in the reaction. In a coordinate bond, you have an ion combining with a polar covalent compound. Okay, so let's first see the first polar covalent compound, which is H2O. Okay, now the ion that joins with this is H plus. So when H plus joins with H2O, what do you get? H3O plus. Okay, the second example that you have is of hydrogen again joining with the other polar covalent compound. What is that? Ammonia, NH3. So when hydrogen joins with NH3, you will get NH4 plus, ammonium. Okay, what is H3O called? H3O? It's called hydronium. Hydronium ion. And NH4 plus is ammonium ion. Okay, so let us see the structure of both these coordinate bond. Yeah, so the coordinate bond is this one here, the bond between the ion and the polar covalent compound. Okay, see in the book. Yeah, now what happens over here? Let's draw water first. So water, how it is, it has one oxygen in the center, and then you have 2 hydrogens. Now I'll draw one hydrogen down here, the other one over here. So oxygen has 6 electrons. From those 6, 2 of them are lone pairs. Other 2 have joined with hydrogen, forming the bonds. Okay. Now when this hydrogen ion comes over here, what is hydrogen ion actually? Normal hydrogen has how many electrons in the outermost orbit? Normally hydrogen has 1 electron in the outermost orbit. How does it become an ion? How does it become H plus? Tell loudly. What happened? How did it become H plus? What made it? It gives away that 1 electron. So since it gave away that 1 electron that it had, it has only a proton in, because it gave away the electron, no? So it has that one proton, and that is hydrogen ion. So hydrogen ion does not have any electron, zero electrons. So to become stable, how many electrons does hydrogen need? It needs two electrons. So what it does, when this hydrogen combines with this water, it will share, it will not share, it will take two of those electrons, but not completely take it. It will take it as a sharing. Like the water will share two of its electrons with that hydrogen ion. So those two electrons now belong to whom? They're not transferred. That means it's not gone away from water. They belong to both hydrogen ion and the water. See, this is only one side is sharing. In a covalent bond, how it was? Both have to share, right? If one atom is sharing one electron, the other atom also has to share one electron. Now those two electrons belong to both. But here how it is. The water will share both of its electrons. So that both electrons belong to both water as well as hydrogen. Okay, so that is the bond here. Now how do you draw this? So first you will just show it like this. H plus plus this water gives, so oxygen here, this hydrogen here, this hydrogen here, the usual ones. So here one X, one dot, one X, one dot. The X belongs to the hydrogen, the dot belongs to oxygen. Then the one lone pair which has not taken part in the sharing, and then the second lone pair which has taken part in the sharing. So next to that you will draw this hydrogen here. So now these two electrons, they belong to both. They are donated, they are shared by the water, but they belong to both. Clear? The next one is more important, where you show it like this. So as a bond, so over here you have three hydrogens around it. So the first this here, this is a single bond, this is a single bond. That's already there. That's part of water. And now here we have the coordinate bond, right? The coordinate bond is drawn as an arrow pointing to the direction at which the electrons were shared. Clear, everyone? Everyone, this is how we draw the coordinate bond, as an arrow pointing in the direction to which the electrons were shared. So water shared the electrons with hydrogen. So you draw the arrow from water to hydrogen. Then last you'll draw one more, and then there you'll write the actual name. Where is it?
And then by when will we end?
5:15.
Okay, because I have to leave right now.
Where? Or to come to campus?
Yes, of the practice.
All right. Just then we'll end in 2-3 minutes. I'll just explain the ammonias also. Okay.
Yes, sir.
So then you'll write H3O plus. Clear of this? How we did this? Same way, you'll have to draw this for ammonia. So for ammonia also, tell me now. So first you have your hydrogen, which has a plus, and then you have ammonia. How to draw ammonia? In the center, what we'll have? N, and then you have three hydrogens. Hydrogen, hydrogen, hydrogen. Right. So all of them have one electron that have taken part. I'm drawing the second diagram. Okay, without the plus in between. This is the structure of ammonia. And here what we have is, what is this? Lone pair. So this lone pair is going to be shared with that hydrogen. So this is what I'm drawing is a second. You draw it the same way how I drew it here, but I'm just showing you what's happening here. So this electron will be shared with this hydrogen. And when you draw the final bond diagram, you'll have so 1, 2, 3. This is a bond that was already there for ammonia. And now you have the new bond here, which is an arrow pointing towards hydrogen. That is NH4 plus. Okay. All right. Draw this. Nathan, you can leave if you want. These are all the different bonds, the whole chapter. This is the whole chapter. So totally how many compounds or how many elements did we see? For ionic, how many were there? 5. For covalent, 8. And for coordinate, 2. So that's 15 different compounds or elements. Okay, you should be able to draw each and every one of them. Okay, complete drawing this.
Yes, sir.
Okay, now just the last topic here is the differences between electrovalent and covalent compounds. The main thing you should know, like all the properties depend on these two things, or this one thing actually. That is electrovalent compounds, they are very strong. Their bonds are very strong. They're held together very tightly and very strongly. And because of that, it's very hard to separate those bonds, right? So if you talk about density, they're very dense. If you talk about their state, they're mostly solids because of that bond. If you talk about boiling point, melting point, they're very high because that bond keeps it very strongly together. If you talk about conduction of electricity, they don't conduct electricity unless they're in the molten state or the aqueous state. Molten means they're melted. Aqueous state means they're dissolved in water. Only then they will conduct electricity. Okay, so you see most of those points will be seen in this differences over here. Now, covalent is how is the bond in covalent bonds? How is the covalent bond? It's weak, right? I told you the name of that force. Do you remember that name, anyone? The bond, the name of the bond in covalent compounds, what's that name? It's VW, like Volkswagen. Okay, van der Waals forces. Do you remember that word? On the first day I told you, see the word is written here. You see this? Van der Waals forces. Okay, that's the name of the bond in covalent compounds. Okay, these forces, are they strong or weak? They're weak. So because they're weak, they exist in all the three states: gases, liquids, or solids. But if it's solid, then it's a soft solid, which means the bond is not too strong. That's why it's soft. Then if you talk about melting and boiling point, they are low melting point, low boiling point. Because with less force or less energy, you can break that force of attraction. Right? The bond is not very strong.
Sir, what is volatile?
Volatile means they evaporate. Okay, volatile means they evaporate easily. So electrovalent compounds are non-volatile, means they stay in their state. They do not evaporate. That solid will remain as solid. Volatile means if you leave it outside, they will evaporate. Solid will just turn into liquid and evaporate. Or if it's liquid, it will just evaporate. Or if it's gas, so it means it's already volatile. So yeah, their covalent compounds are volatile. Then conduction of heat. Conduction of heat, how much heat transfers. So ionic compounds are good conductors of heat, and covalent are bad or non-conductors of heat. You should think of an example. For covalent, think of water. Okay, water is a bad conductor of heat, right? Or a non-conductor of heat. Like heat passes, everything will transfer heat, but the thing is, it takes a long time for it to get hot. That means it's a bad conductor. If it gets hot fast and transfers the heat fast, that means it's a good conductor. Okay. Conduction of electricity. So as I said, ionic compounds in the solid state, they are non-conductors, but in the molten or aqueous state, they are good conductors. Molten means liquid state. How do you convert into a liquid? How do you convert the ionic compounds into a liquid state? By heating it. So when you heat it, it becomes hot. That's why it's called molten. You know, lava, we say, is molten lava, means it is hot. It's supposed to be solid, but because of the heat, it has melted and become liquid. So that's called molten. So ionic compounds in the molten state, they conduct electricity, or in the aqueous state. Aqueous state meaning if it is dissolved in water. For example, NaCl, sodium chloride. If you take the powdered sodium chloride, does it conduct electricity? No. But if you heat it, it becomes liquid. That time it conducts. Or if you put it in water and make it into an aqueous solution, then also it will conduct. What about covalent compounds? In the gaseous or liquid state, they are non-conductors. In the soft solid state also, they are non-conductors. Okay, so they don't conduct electricity at all.
Non-conductors.
Yeah, they're non-conductors. Reason is non-polar covalent compounds, example CCl4, contain molecules and not free ions. Hence, they are non-conductors. Okay. See, there's molecules and there are ions. There are ions. If there's only molecules, molecules means the atoms have combined and they become a stable structure. That is molecule. They don't conduct. But if those molecules separate into ions, then they will conduct. Okay. Now, if you look at NaCl, if you put NaCl in water, what happens to NaCl? It dissolves. But what is actually happening to this molecule of NaCl? It doesn't remain as this NaCl molecule. It splits into ions, Na plus and Cl minus ions. See, the molecules split into ions. As long as they stay as molecules, they are non-conductors. When they become ions, then they are good conductors. Okay, so that's the thing. So ionic compounds, they all turn into ions, and covalent compounds, they don't turn into ions. What happened? Distracted? Um, there's a few more things over here. Electrolysis. There's a chapter called electrolysis in chemistry. In that you learn about electrolysis. But electrolysis means just passing electricity through that substance. Okay. So for ionic compounds, they can be electrolyzed in the molten or aqueous state. Covalent, they cannot be electrolyzed. Then solubility, soluble in water, insoluble in organic solvents. Covalent is soluble in organic solvents, insoluble in water. This last three topics we will discuss about it later on. Okay, the solubility, the reactions, and dissociation, because there's a little bit of explanation that's needed for that. Okay, here we can see the differences between electrovalent and covalent bonds. So we had seen most of them. We just left a few of them at the end. So this is from your textbook. That is Selena. Let's just go through all of them once again. Uh, yeah, first one is their nature. How do they feel? How do they appear? What state are they? So electrovalent are generally what state? They're solids, and they're hard solids. Okay, hard solids means they're very strong, they're hard, they're dense. You cannot easily separate the ions. Okay, covalent, the bonds are not very strong, so they're generally, if they're solids, then they're soft solids, or they're mostly liquids or gases, because the bond is very weak. That's the first thing we saw. Second thing we saw about boiling and melting point. So electrovalent, how are their boiling and melting point? Is very high. See, just you have to understand that electrovalent bonds are very strong. So to break that bond, you need a lot of energy. Okay? So when you boil and melt, you're breaking that bond, but you need a lot of heat for breaking that bond. So boiling and melting point is very high for electrovalent. And for covalent, they are volatile. Volatile means they evaporate easily. The bonds just break automatically. So you don't need too much heat energy for breaking the bond. So it has low melting point and low boiling point. Then what happened? You're coming late. Huh?
I just woke up like 10 minutes ago.
Yeah, I should come first. Get up earlier. Only old people sleep in the daytime.
Huh?
Only old people sleep in the daytime. Don't sleep in the day.
Yes.
Who all sleep in the daytime? All of you sleep in the day? I never slept in the daytime. Sleep in the night. Okay. Second point. Yeah, we saw boiling and melting point. Third point, conductivity. Now, which are good conductors of electricity? The electrovalent. Electrovalent are they conduct electricity, but not in their solid state. Only in their which state? Huh? How do you make it liquid? Yes, in the liquid state only they conduct, but how do you make it into a liquid? How do you make these solids into liquids? See, electrovalent compounds are all solids, and we are saying that they only conduct in the liquid state, right? How do you make those solids into a liquid is my question. Heating it. One is by heating and melting it. That's called the molten state. The second way to make it into a liquid is dissolve it in water. Okay, so when you dissolve it in water, we call it aqueous state. So they conduct in two states, that is in their molten state or in their aqueous state. Now, molten state means you're heating it so much because of the heat, the bonds break. So when the bonds break, these ions that are formed, they are free to move around. Okay, these ions, they move. We are going to study a chapter called electrolysis in 10th standard. In that time, we'll be learning exactly how these electrovalent compounds, how they conduct electricity. For example, NaCl. What happens to NaCl? They will separate into Na and Cl. Now, Na is positively charged, Cl is negatively charged. So the positively charged molecules will move towards the negative electrode. See, you're putting positive electrode and negative electrode inside that liquid. So the negative ions will move towards the positive electrode, and the positive ions will move towards the negative electrode. And that movement, continuous movement, will cause that particular liquid to conduct electricity. Okay. What about covalent compounds? They are non-conductors. Whether it is solid or molten or aqueous state, they are non-conductors because there are no free ions. They are only molecules. Molecules need to split to become ions. Only if ions are formed, then they will conduct electricity. Right? Remember, molecules have to split into ions. If they remain as molecules, then they don't conduct. If they split into ions, then they will conduct. Okay, so keep this in mind. It's very useful in many chapters. This molecule splitting into ions is there. Then dissociation. Dissociation is when you put them in water. For example, NaCl. If you put NaCl in water, what happens to NaCl? They will what? Separate. The word separate is called dissociate. So dissociation is taking place. This is a dissociation. NaCl will dissociate to form Na plus and Cl minus ions. And these ions will conduct, they will move around within that liquid. Na will move towards, Na is positive, right? So positive will move towards the negative electrode. And the Cl, which is negative, will move towards the positive electrode. That is dissociation of the electrovalent compounds. Now what happens for the covalent compounds? Here also same thing, you'll see they split. Okay, some of them, not all of them. For example, water. When you pass electricity through water, water will split. But pure water will not split. Pure water is what? It's a non-conductor of electricity. When you pass electricity through pure water, what happens? Nothing happens because pure water is a non-conductor of electricity. But if you add something to water, some impurity, some salt, or some HCl, or some acid, any acid, then the water will split. How will the water split? H2O. H2O will split. How does it split? Tell me. Into hydrogen and oxygen? No. That's later on. But first you will see H2O will split into H plus ions and OH minus ions. See, they will become ions. Okay. So this process is called ionization. Ionization means a molecule splitting into ions. Then why on this side, here we are not calling it ionization. Here what we are calling it? Dissociation. Here also NaCl is splitting into Na plus and Cl minus ions, right? So why don't we call this ionization? The reason is because Na and Cl are already ions. So here it's not ionization. They're already ions. They're just separating. So what do we call this process? Dissociation. But on the other hand, for water, they were not ions. H2O was a molecule. And the molecule is turning into ions. It's becoming ions. So that's why this process is called ionization. Okay. So the reaction for dissociation and ionization look very same. They're becoming ions. But for electrovalent compounds, that splitting we call it as dissociation because they're already ions. They're not molecules. They're already ions. For covalent compounds, we have to call it ionization because they were not ions at all. It was a molecule. H2O was a molecule splitting into ions. Is that clear? See, here it's written here. Covalent compounds do not have ions, so they do not dissociate. If they were already ions, they just dissociate. Here they're what? Covalent compounds are what? Are they ions? What are they? Molecules. Come on, don't forget. This is a molecule. H2O is a molecule. So the molecule is splitting into what? Ions. So this process is called what? Ionization. When molecule splits into ions, it is called ionization. Okay. Okay, Nathan, Ahmed, and Ryan, you joined 20 minutes late, 15 to 20 minutes late, and your cameras are off. So I don't see a reason for you being in the class over here. You're joining in late, and your cameras are off, and you're waiting for me to call you out. You come before me and wait in tuition, no? Why do you have to come after me and make me wait? Nathan? Okay. The last two more points are here. Solubility. So electrovalent compounds, they are soluble in water. Just think of NaCl, salt. When you put salt in water, what happens? It dissolves, right? So all electrovalent compounds are soluble in water, but they're insoluble where? In organic solvents. Okay, so remember these are two types of solvents. Water is one solvent, which is called the universal solvent, and the other solvent is organic solvents. Organic solvents means solvents that contain carbon in them. Anything that has carbon is called organic. Okay, so they are soluble in water but insoluble in organic solvents. Now, covalent compounds are exactly the opposite. They are insoluble in water but dissolve, means they're soluble in organic solvents. Okay, just memorize that part. The reason is here. As water is a polar compound, it decreases the electrostatic forces of attraction, resulting in free ions in aqueous solution. Hence, they dissolve. Polar compound. What's a polar compound? What is polar?
Which is not equal.
What is not equal is the charge distribution. Okay, unequal charge distribution. Like you'll see one side there is more positive, other side more negative. That is unequal charge distribution. We saw the polar compounds. Which were the polar compounds? There were just two polar compounds, two polar covalent compounds. Which were the two? Ammonia and water. They were the two polar compounds. So here water is a polar compound, and because of that it decreases the electrostatic forces of attraction. See, there's charge distribution. Okay, water, how it is, hydrogen is positive and the OH is negative, or whatever. If you see the structure of this, how it is, they have hydrogen on both the sides and you have oxygen in the center. Oxygen has 6 electrons, only 2 of them take part in the sharing, and here there is 2 lone pairs, right? So because of this lone pair, this whole oxygen is negatively charged. Okay, and that decreases the electrostatic forces of attraction uh, of what, of the whatever you put inside water. For example, if you put NaCl in water, the NaCl's electrostatic forces of attraction decreases. NaCl, that force of attraction decreases, and because of that it dissolves. Okay, um, how is it for the covalent? As organic solvents are non-polar. Okay, organic solvents are non-polar. Just remember that. Hence, these dissolve in non-polar covalent compounds. And we'll do that again. As organic solvents are non-polar, hence these dissolve in non-polar covalent compounds. Okay, it's like this. Polar substances dissolve in polar solvents. Non-polar substances dissolve in non-polar substances. That is one rule. Just memorize that rule, write it down. What is that? Polar substances dissolve in what? in polar solvents. And non-polar substance dissolve in non-polar solvents.
One of polar substances can only be dissolved in polar solvents, and
Yes.
non-polar substances can only be dissolved in non-polar solvents.
Yes.
So they can't interchange.
No, polar will not dissolve in non-polar, and non-polar substances will not dissolve in polar solvents. So water is what? Polar or non-polar? Huh? Water is polar. What about electrovalent compounds? They're also polar. That's why polar substances dissolve in water. It's polar to polar. It's like, unlike. Okay. So, like if you see NaCl, Na is positive, Cl is minus, no? So that's a difference in polarity. One is positive, one is negative. So all electrovalent compounds are like that. They are polar, so they dissolve in water. Covalent compounds, there are polar and there are non-polar. Both are there, right? So polar will dissolve in polar, non-polar will dissolve in non-polar. That is the general rule. You can use it anywhere. See, I'll read this. As organic solvents are non-polar. Organic solvents are non-polar, so these dissolve in non-polar covalent compounds. So non-polar dissolves in non-polar. Okay, the last difference over here, rate of reaction. They show rapid speed of chemical reactions in aqueous solutions. So they react very fast. Since free ions are easily formed in different solutions, they unite very fast, forming compounds. So they're all ions. Here they're all ions. Ions means positive and negative separate. So the reactions take place fast. The positive gets attracted to negative, negative gets attracted to positive. That happens fast. In covalent compounds, the rate of reaction is slow. In covalent compounds, old bonds are broken and new bonds are formed. Thus, the reaction is slow between covalent compounds. See, bonds have to break. See, like H2O has to break into form ions. This process of breaking into ions takes some time, and then that has to again join with other ions and form new compounds. So that takes a little bit of time. That's why covalent compounds are slow in reactions. For electrovalent, how it is, they're already ions, so they can easily join with opposite charges, and the reactions can take place fast. Okay, this is the difference. Is everyone clear with the differences between electrovalent and covalent compounds? Okay, so that is from page 31 in your book. Next was about coordinate bond. We saw about coordinate bond in the last class. What is a bond between? Coordinate bond is between what two things? Coordinate bond is between what? You are not studying. You can see what two atoms.
Ion and covalent compound.
Yes, ion and covalent compound. So there were two coordinate compounds that we saw. Which were the two compounds that had coordinate bonds?
Hydrogen and water.
Hydrogen and water that form hydronium ion. That was one. Next one. First was hydronium. That is H plus H2O. That was H3O plus. This H3O plus is called hydronium. This is one. The bond between the hydrogen ion and the water was a coordinate bond. Second coordinate bond is between what? Hydrogen and ammonia.
Hydrogen and
So the bond between the hydrogen and ammonia was a coordinate bond. Okay, this chapter is done. Your work when you go back is to study, to go through all the question answers from this chapter. You cannot miss out any point, any topic, anything from this chapter. From chapter 2 exercise, solve every question that is there. Study the whole chapter, study 2-3 times. Read, write down reactions, write down electron dot diagrams. That's the only way you can study and get good marks. Okay. All right. So we're done with chemistry. Any doubts? Anything you want to ask regarding this chapter?